Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. So we're going to talk about the trapezium rule now. It's also another method of finding the area under the curve as well. Before I proceed, don't forget to like, share, and subscribe. And if you have any question, please feel free to contact me and I'll get back to you on it. And if you've not clicked the notification bell, I don't know what you're waiting for. Please do so that when I post new videos, you'll be the first person to know. Now, the trapezium rule is a way of estimating the area under the curve. Okay, the trapezium rule gives us a way of estimating integral. So usually, the trapezium rule is usually said not to be exact because there could be room for errors. Unlike when we use the definite integral method I've talked about in the previous videos. Okay. And so basically, the trapezium rule works by splitting the area under a curve into a number of trapezium, which we know the area of. So because we know the area of a trapezium is 1/2ab plus times h. So we can use that now to solve. Because I'm aware some of us do take notes from my videos. So I'm going to write what I said down so that it will be easier for you to make a note of it and revise it later. All right. So the trapezium rule. The trapezium rule is a way of estimating the area under the curve. Okay, it's a way of estimating the area under the curve, and it gives us a it just basically gives us a method of estimating the integrals. Okay, so it gives us a method of estimating integrals. Okay, so we use this to estimate integrals. And also, the trapezium rule, it basically works by splitting the area under the curve into a number of trapeziums. So the trapezium rule works by splitting the area under a curve into a number of trapeziums. Which we know the area of. Oh, okay. So that is basically what the trapezium rule is about. All right, let me try and see if I can explain this more using a graph. So let's assume we have this here, and also we have that here, okay? And we have a particular curve. So let's say I have this curve here. So the curve is from this point like this, all the way up to this point like this. Okay. And I want to find the area between, let's say I want to find the area between, let's say between, um, let's say this point here, XO, let's call this XO. and xn, this point here, xn. So basically, or let me use a red pen for this. So to make it clearer, so xo, and make this xn, all right? So I can then try to draw the lines. So it's gonna be from this point all the way here. Let's call this xo. Then from this point as well. So let's say from this point all the way down here is xn. Okay. So now, so I want to find the area covered by this. So basically, you can easily, because every point has a coordinate. So I can also say that this point here is going to have another y coordinate. So I'm going to call this y coordinate yo. All right. Then I'm going to call this y coordinate here, I'm going to call it, let's call it yn. Okay. Now I want to find this curve. So what I'm going to do is that I'm going to break this into trapeziums, okay? Equal trapeziums with equal lengths, okay? Let me see if I can try to do that. All right, so I'm going to break this into equal trapeziums. So let's say we have, let me break it from this point here, okay? Then let me break it again from this point here. Looks to be, yep, this place as well. All right. So push this a bit up. Okay. Now let me break this again. From this point here, looks like an equal part. And also let me break this again into this. Oh no. Let me break it into this point here. Oh no. So this point. Oh, nope. This one. Get this one out of the way here. Okay. Then this one from this point here. Okay. All right. So you can now see that I've broken this into equal parts, and you can see the distance for each of them from each point from here to here as let's call this the height. So that means the distance from here to here for each of them are equal, and let's call it h, which is the height. Okay. Now, just for me not to make some assumption here. So when I say trapezium, I'm assuming that you know the shape of this, that it looks like this. So some people can draw it this way, right? So some people can draw that this way, all right? Or you can draw it standing, okay? If you want to, you can draw the standing as well. So it looks like this. This is what we call a trapezium, all right? So this is what we call the two parallel side is A and B, and the vertical side here is called the H. So that means here, this is the H, this is the A, and this is the B, okay? So this is the trapezium, okay? This is the shape of the trapezium. And also, if you want to find the area of a trapezium, the area of a trapezium of this shape is equal to 1/2. Get this a bit up. So 1/2 A plus B multiplied by H, okay? So that's how you get the area of a trapezium. So now if you look at this, you can see that each of this look like a trapezium. 1, 2, 3, 4, 5. So you can see from XO to XN, are broken into 5 trapezium. So if you look at the first one, you can see that this one here, you can see this is one of the trapezium. If you look closely, this is it, like this. Are you seeing it? That's one. Then you go to the next one. You see another trapezium here. This is 2. You go closely, you see another trapezium here. This is 3. Are you seeing it? You go again, you see another trapezium here. So this is 4. Are you seeing it? And you go closely as well, you see another trapezium here. And this is what? This is 5. So that means basically we'll have 5 trapezium. So what happens is that if I found the area for the first one, the second one, the third one, the fourth one, and the fifth one, I'm going to just add them together, and that will now give me the area under the curve. Okay? Okay. So so that is that for that. So I'm going to remove this thing so it will still look clean, and that. So for this now, so like I said, because I know some of you do write notes, so I'm going to just write what I just said. So if we want to find, okay, if we want to find the area under a curve, this is xn, curve between the points XO and XN, all right? We divide the interval up into smaller intervals. Okay, so as you can see, what I did, XO to XN, I divided into smaller intervals, okay? Now, with each of them having its own length, right? So each of which has length h. Okay, so the length of each of the intervals is what? H, as you can see from that. Now, there is a proof to how to get the total area, but I'm not going to go into that, but I'm going to just say the formula, all right? I'm going to just write down the formula for trapezium rule here, but there's a proof on how to get each of this, okay? So basically, what we are saying is, now when you look at this closely, each of this now, so we call this x1, we'll call this x2, we'll call this x3. Now, as well, if you call this x1, the y values for this one is going to be called y1. Are you seeing it? The y value for this one as well is going to be called what? y2. Are you seeing it? And the y value for this one as well is going to be called y3. Okay, so that means when you divide it into smaller values, they're going to have values between between yo to yn, and there'll be different y values between. And between xo and xn, there's going to be different x values between them. All right, so how do you now find it? So now, therefore, to find the area, okay, now the area for this now, so the area, how do you get the area? The area is going to be equal to the integral sign. So we're going to integrate between xn and xo. So xn is going to be the upper limits. Xo is going to be the lower limits. And we're integrating the particular function in respect to x will be equal to 1/2, okay? The height the height for this is going to be YO plus, so you're going to give it 2. So now, so the YO is the value here. You have the YO. Then we now have 2 into bracket Y1 plus Y2 plus all the way to YN minus 1, close bracket, plus YN. Does that make sense? So what we are saying is that you keep on adding all the y's in between. You're going to keep on adding them, then multiply it by 2. Then the final one is going to be the yn. Okay? And this is the what? The area on how to find the area for a particular what? Using trapezium rule. Okay? So this is how to find the area for that. Yep. All right. So also there's also a formula as well on how to find the height. Okay, there's also a formula on how to find the height as well. So to get the height, so basically it's based on the premise that the original interval is split up into n smaller interval. Okay, so if the original interval all right, was split into n smaller interval, then h is given by, so h is given by h will be equal to h will be equal to xn minus xo divided by n. So h will be equal to xn minus xo divided by n. Are you seeing it? So what we are saying is that if, for instance, I want to divide this into 5 equal intervals, so it's going to be the value of xn minus the value of xo divided by 5, okay? So basically, we can now say for this is that the value we get here, so we can now say where, so we can say where xo is equal to the lower limit, xn is equal to the upper limit, and n is equal to the number of strips. Okay? Equal to the number of what? Strips. So for instance, what I'm saying, like what I just said, is if, for instance, I wanted to break this into 5, that the n is going to be the strip. So the n is the number of trapezium you are referring to. Okay, so, and like I said also, that the height has to be consistent. So basically, you are dividing it into equal height throughout the process. So let's then write out the steps on how to solve the trapezium rule. So the 5 steps. So sometimes I call it steps, sometimes I call it rules. Okay. The 5 steps when you're solving this. Okay. Number 1, The first thing to do is to determine the value of h by using the formula, the xn minus xo divided by n. And also you need to know the number of strips, okay? So you have to determine the value of h by using the formula and knowing the number of strips. Okay, knowing the number of strips. And all right. Now, after you've done that, the next thing you need to do then is to now derive all the value of x using the value of h gotten from step 1. So you then have to then derive all the values of x okay, using the value of h gotten from step 1. Okay, then number 3, when you've done that, then you have to now get the corresponding value of y for each of the value of x, okay? So you then have to then get the corresponding value of y for each value of x. Then after that, you then, when you're done with that, you then apply the trapezium rule formula. Then you apply the trapezium rule formula. After which, you will then simplify. Okay? So this is how you solve using what? Trapezium rule. So you determine the value of h using the formula. You derive all the values of x. Then also after that, you now apply the trapezium rule, and you now get to use the formula for that. Okay? All right. So we're going to pick some examples now. All right. So let's solve an example. Let's do this. So let's pick an example, just one, to just explain the concept for this. So let's assume we are told, question 1, evaluate, okay, between 1 and 0, the square roots of 3x plus 1 using 4 strips. Now, we can solve this question. If, for instance, it was not written using 4 strips, we could have used definite integration to solve this, convert it to index form, then apply the relevant rule, either substitution method, integration by substitution, or depending on the one you want to use here. Then after we'll solve. But when you see things like using 4 strips, definitely you need to know that this is the trapezium rule that you have been asked to use. All right, that means the question is asking you to use trapezium rule to solve this. So what's the first thing to do? We have to apply the trapezium rule here. So number 1, step 1. What does step 1 say? Step 1 says that we need to determine we need to determine the value of h by using the formula and knowing the number of strips, okay? So let's see what's the value of h here. We know that h, I told you that h is equal to xn minus xo divided by what? N. This was, I think it was in the previous slide. Yep, so I told you xn minus xo divided by n. So since we know that, so let's go. So what is our xn here? Our xn, which is the upper limit, is 1. What is our xo? Our xo, which is the lower limit, is 0. Okay, so this is 0. Okay. Okay. And the n is the number of strips. The number of strips we're giving here was 4. All right. So then we'll now apply it here. So the h is going to be equal to 1 minus 0 divided by 4. And this is going to give us what? 0.25. So therefore, the height of what we are looking for is 0.25. All right. Now let's go to step 2. Now, what does step 2 say? It says that we have to derive all the values for x, okay, using the value of h gotten from step 1. All right, so we'll have to derive all the value for x, given that, okay? So let us derive that. So we have to derive all the values for x, so that's step 2. So let's go. So step 2. So we're already given the lower limit, which is the xo, was equal to 0, and the upper limit, the xn, was equal to 1. So we need to derive all of them. So we're going to start. So the first one is 0. Remember that the h breaks up the curve into equal parts. Is that okay? The h breaks up the curve into equal parts. So it breaks it up into equal parts. So what do? So because of the height, you keep on adding the 0.25 to each of the x values. So now, the first one I have here, the first x value I have is 0. The second one is going to be 0 plus 0.25. The value is giving me 0.25. Then this 0.25, I'm going to add another x value, the h, so it's going to be 0.25 plus 0.25, and that'll give me 0.50. So this is because we're going to get up to 5 strips, okay? So 0.5 is going to be 0.50 plus 0.25. So like I said, if this was the curve, do you understand? And we're told that the beginning was 0, then the final end was 1. Are you seeing it? And we're having 4 strips. 1, 2, 3, 4. Are you seeing it? So that and the distance between each of them are equal. So we're looking for the values for each of this one. So the first one is 0. The next one is 0.25. The next one is 0.5. So we want to look for all the numbers for that. So 0.25 plus 0, and the distance here, which we have calculated, which was the h, which is constant, is 0.25, okay? So 0.50 plus 0.25 will give us 0.75. 0.75, okay, plus 0.25 is going to give us what? 1. Are you seeing it? So that means we're going to have what we are looking for here. So we have 0, 0.25, 0.5, 0.75, and 1. So what I'm trying to say is that if this was the curve, let me just make a makeshift curve here. Okay, a makeshift curve. Okay, so what I'm saying is that if this was a makeshift curve, all right, and we're told the xo was 0, the x1 was what? 1. And we have 4 strips. So we have 1, 2, 3. Okay? Just bear with me in this. Let me clean this one and make it a bit. So we have something like this, something like this. So we're told we have 1, 2, 3, 4 strips, and the height is the same. So the first one is 0, and we're told that the distance for each of them, h, was equal. You understand? The height is always equal for each of the strip. Are you seeing it? The height is equal. So if the first one is 0 and the height is 0.25, so that means this is going to be 0.25. Then you add another 0.25, this is going to be 0.5. You add another 0.25, it's going to be 0.75. And this is 1. Can you see? So because the question said we had what? 4 strips. So because we had 4 strips, so we've calculated the x values for each of them. So that means I can now say for this question now that the x values that we had for this, the x values we had is 0, 0.25, 0.50, 0.75, and 1. And those are the x values. Are you seeing it? Now, let's go to step 3. Step 3 now said that we need to get the corresponding y values for each value of x. So to get the corresponding y value, we need to substitute x into the original equation, okay? So I can add this here so that you will, so by substituting the x values from step 2 into the original equation. All right? So that this will make it clear. So how do you get this? So the x values we got from step 2, we need to then substitute it into the original equation to get the y values. So that means these x values, I need to substitute it into the original equation here to get the y values. So what are we going to do then? So we do what we always do. We keep on solving it correctly. So we'll now do it. So we'll go to step 3 now. Okay. So we go to step 3. All right. We'll go to step 3 for this. So we keep on substituting. So the x values we had was 0. The first x value we had was 0. So to get the y value for that, we need to substitute it to the original equation and was square root of 3x plus 1. So the y value we had, was equal to square root of 3x plus 1. So that means to get the corresponding y value, you need to put 0 into x, so that becomes square root of 3, 0 plus 1. And when you press your calculator, that will give us 1. We do for the next x value. The next x value we have is 0.5. So number 2, we have 0.25, or let me bring this a bit down. So number 2, we have 0.25, and that will give us square root of 3, 0.25 plus 1, and that will give us 1.32. Okay, number 3, the next one we have was the third one, 0.5. So we have 0.50 will be equal to square root of 3, 0.50 plus 1, and that will give us 1.58. Number 4, the same thing. We'll get the corresponding y values. That is 0.75. So we'll get 0.75 will be equal to square root of 3, 0.75 plus 1, And when you press your calculator for that, it will give you 1.80. And number 5 is 1, which is equal to square root of 3, 1 plus 1, and that will give you 4. Square root of 4 is going to be 2. So now we can now complete the table we had before. So the table we had before, the table we had, let's get it out. So the table we had before, we had this table on X, right? So we're going to add the Y values now, because now we do have the Y values. So we can do this. So previously we said the X values, all right? So the X values we had, the first one was 0, but the corresponding Y value now is 1. The other one we had was 0.25. The corresponding Y value is 1.32. We had 0.50. The corresponding Y values is 1.58. We had 0.75. The corresponding Y values is 1.80. And we have 1, and the corresponding Y values is 2. So now we know the X values and their corresponding Y value. Okay. So that means we can now easily explain this a bit. So what I'm going to do is that I'm going to, for the X values now, okay? So we can now easily talk about which is which now. So the first one, to make it very clear, so that means this is our X naught, right? This is our Xn. Are you seeing it? So this is our X1. This is going to be our X2. This is going to be our X3. So if this is X3, our Xn then is going to be what? X4. Okay? Then we can also do the same thing. So these values here we're referring to our X2, our X3, and our X4. Then we can do the same thing for the Y as well. We can draw just to make it clear. Okay? So we can now say that we can now get the Y values, so that we already got the Y corresponding Y values for this. So the corresponding Y values for this is going to be, this is the Y naught, it's going to be Y1, it's going to be Y2, Y3, and Y4. So these values we have here is the Y1, Y2, the Y3, and the what? The Y4. All right, so let's go to step 4. Now, step 4 said that we need to apply the trapezium rule formula. All right, the trapezium rule formula. All right, so let's do this quickly. So step 4. So step 4, we are applying the formula now. So it's going to be, we're integrating between 1 and 0, the square root of 3x plus 1 will be equal to, okay, 1 over 2. So if you remember the formula, let me go back to that slide. So I told you it's going to be 1 over 2 h, y0 plus y1, y2, yn minus 1 plus n. Are you seeing it? So we're going to do the same thing now. So we're going to use the formula now to solve it. So let's go. So it's going to be equal to 1 over 2 times h into bracket y0 plus 2, y1 plus y2 plus yn minus 1, close bracket, plus yn. All right? Now, but we know our n is 4, right? In this question, but the n but our n is equal to 4, okay? So therefore, we can now write this formula again because the n was given in the question and the n was 4, okay, the number of strips. So that means we can now rewrite our formula now to be 1/2 times h into brackets y0 plus 2y1 plus y2 plus, now n is 4 minus 1 will give us 3, so it's going to be y3, that's the maximum you can get here, plus y4n. Is this making sense? So let's go. So let's solve this. So now they're getting the area now. The area, this will be equal to 1/2 times, what was the h? I think it was 0.25. Yes, we got it at 0.25. So the h was 0.25 into brackets. Now the y naughts, so this is values, the y naughts, the y1, the y2, the y3, the y4. So we're going to just substitute it into this now. So the y naught we had there was 1 plus 2 into brackets, 1.32, which was the y1. The y2 was 1.58. The y3 was 1.80, okay? 1.80 plus the y4 is 2, like this. Now, you put this into your calculator, and this will give you, that will be step 5, which we're told to simplify. Step 5, you press all this in your calculator, and the area will be 1.55 units squared. That's how you find the area using trapezium what? Trapezium rule, okay? So basically, the first step you do, you find the h. When you find the h, you find all the x values using the h, okay, between the upper limit and the lower limit. There you get the corresponding value for the y's. You will now use the formula, and you get the answer to be the area. So I'm going to go to the next video, which is finding the equation of a curve from its derivative. All right, so we're done with the area under the curve for now. So I'm going to just go to finding the equation of a curve from its derivative. So it's important that you subscribe and you click the notification bell so that when I post the next video, you'll be the first person to know. All right, so I'm going to see you soon, and we'll talk about that very soon. Okay, so I'll see you in the next video, and make sure you review all the videos we talked about. And if you have any question, please let me know, and I'll get back to you as soon as I can. Thank you very much.